Hello, everyone. Welcome to a new episode of our Lunch and Learn series, where we bring interesting topics from the world of tech and web development right to you. Remember that if you're watching us live, you can ask your questions on the YouTube chat, and we will answer all of them at the end of the stream. Today, with us, we have Miguel Marmol, a software engineer who works with our client Zebra as a Java developer. He will tell us all about the Scala basics. Hey, Miguel, how are you?
Hi guys, I'm doing good. How about you? Hope everything is ready. Everyone is ready to learn some Scala stuff.
Yeah, we're absolutely ready. And please take it away.
So, hi everyone. I'm Miguel Marmol. I work as a lead developer for Zebra Technologies, which is one of our biggest clients. And today I want to share some knowledge about the Scala basics. So this is the logo of Scala. And what we are going to cover today is what is the Scala, what are some of use cases of Scala, how to get started with the Scala, and I would like to show you some code related to functional programming in Scala. And finally, we will have some questions and answers. So let's start. So what is a Scala? A Scala stands for Scalable Language. It was created by Martin Nudersky. It runs on Java virtual machines, which makes it interoperable with Java. So Scala is also a blend of object-oriented and functional programming concepts in a statically typed language. What do we mean by a statically typed language? Is basically when those are the languages that the compiler tell us if there is an error. So before running, the compiler will tell us that all the types are properly declared. So So I'm going to talk about the Scala use case. So in web development, Scala is used for building web applications and RESTful APIs. Frameworks like Akka, HTTP, and Play are popular choices for Scala web development. So another use case of Scala is big data processing. So Scala, along with the Apache Spark framework, is widely used for big data processing and analytics. Another use case that we have is concurrency and distributed system. Scala support for concurrency, along with frameworks like Akka, makes it suitable for building concurrent and distributed systems. And finally, we have microservices architecture. Scala, also combined with Akka, is used for building microservices architectures. Its support for current concurrency and distributed systems aligns well with the requirements of microservices. So how to get started with Scala? First, I assume you guys have installed in your machines Java. The next step is to download the Scala from the Scala site. Once we install Scala, we need an IDE to write some code. This will, you can write the code also in a notepad, but you will need a builder tool called SVT. So it's better to use directly the IDE, which already has this, and you don't have to deal with that. So if we go to this site, we will download the community edition, which is a free edition. But if you want, you can also download the ultimate edition, which is a paid edition. Okay, so once you install the IDE, it will look like this. Okay. So here, the first thing we need to do is to install the plugins that will allow compatibility with the Scala. So in my case, I have already installed it since I use it all the time. But you will have this install option available here. So you will click here, it will install, and it will restart the IDE. Once the IDE is restarted, you will see something like this. So to start and create our project, we are going to hit on new project. So this window will pop up. We're going to say Scala Basics. And we are going to create. As you see in Scala, we also have, like in Java, those who are familiar with Java, you can see the source, main, test folders. Here, Scala. In Java, you have, instead of Scala, you have Java, okay? So we are going to create a new package. We're going to call it conjobsitting.scala. And inside of this, we are going to create a Scala class, name functional, programming. Okay, so I'm going to inherit from app to make this program executable. So for example, if I write hello Scala, we will see in the console sorry, it's running. The first time takes time, sorry for that. Okay, so we already have our hello, with the typical hello world. Okay, so as I mentioned before, Scala supports object-oriented paradigm. So we can define a class named person, which will take an argument called name of type string. And inside, we will declare all the methods that we need. In this case, I'm going to declare def with the keyword. Sorry, I'm going to create a method called apply with the keyword def. We will take it will take an int called age. And we are going to say with an interpolated string, which is a string that can concatenate strings, variables inside its content. So for example, I would put, I have aged age years. So as you see here, I don't need to use the plus operator to concatenate this variable with the rest of the text that I want. I just use this. So what is special about this method apply? The special thing about the apply method is when we declare an instance of this class person, let's say Miguel, new person with my name. We have this instance, right? We can call, sorry. We can call this apply method like we will do in any other language. So we call the method apply. We give the argument, and that's it. But Scala allows this method to be called as a function. What I mean with this is we can do Miguel, and it will take the argument 41. So in this way, we are invoking the instance of the class person. The instance is called Miguel. So we are invoking Miguel as a function, which is equivalent to do what I wrote before. Okay, so why this is important? Because Scala runs on a virtual machine, right? So the JVM knows what an object is because the JVM was built for object-oriented paradigm, but it doesn't know what a function is. And functional programming consists of composing functions. We have to pass functions as arguments, and we need to return also functions as arguments, as results, sorry. So how the Scala people manage this problem so they can use functions as arguments and functions as results? They created a trait called function X. So you will be wondering what a trait is. So trait is nothing but an interface. Like in Java, is the similar to an interface in Java. So I'm going to give you an example of how this function X trait works. So let's say I'm going to declare this simple incrementer variable, and I'm going to say that it's going to be a new function 1 of int and int, and this will override the particular apply method that we talked before. So argument, and since that's the incrementer, we are just going to do by 1. Okay, so here we're saying that our function will receive an int and will return an int. So then we can call simple incrementer, and just with the argument, let's say 2. So this will return 3. Okay, so this is the equivalent to say simple incrementer dot apply and receive the 2. So what we have done here is just we have defined a function. So simple incrementer is a function. And now we are calling the instance of this trait as a function. Okay, so all Scala functions are instances of this function x types. So here we have function 1, function 2, until function 22. So we can define functions that take until 22 arguments. Okay, so I'm going to give you another example with the use of function 2. So I'm going to define a string concatenator, which is going to be an instance of the trait function 2 that will receive a string, another string, and it will return a string. Okay? So we are going to override the apply method. See, here already the compilers have inferred that we are going to receive 2 arguments as a string and return a string. So since we are going to concatenate, we are going to say that the result is going to be the string concatenator. Okay, so let's use this string concatenator. So I will do I love, and the second argument will be Scala. So let's print this result. Sorry. So you can see how it is going to concatenate. Oh, sorry. Like this. See, I love Scala as the string concatenator. So as you see, this is a lot of boilerplate code. So Scala offers you what they call syntax sugar. that makes simpler to write the same code. So we are going to create another function called doubler, which will receive an int and int. So here we are saying this doubler is a function one of int and int. And it will be equals to, it has to receive an int, right? So we are going to say x as an int. And it will return another int, which will be twice this argument, okay? So see how it has been reduced to just this. So this is the same writing new function one of int and int override def apply x int that returns an int, which is 2 times the argument that we received. So this code block is the same as we have here, but this is much easier to read. So that's one of the syntax sugar that we have. We could also make it more easy to read if we define it like this: another doubler of int and int. This is the same as defining function one of int and int. And then the rest, x int, and twice. So if you see, if we call these doublers, they should give us the same outcome. See, the same. Since the Scala has this, it can infer the type, we can omit this. And you will see that the compiler will still know that is the function. See, it receives an int and returns an int. So that's what I wanted to show you, a very bit taste of Scala. So now we have some questions and answers.
Right. Thank you, Miguel. That was very nice. We got to see a new language that I honestly have heard about a lot, but never really got into seeing how it actually looks. It's interesting. I always heard it compared to, for example, Python. It's used a lot in data engineering for Spark and stuff like that. Very nice to see the showcase of it, the syntactic sugar of it. Makes it really easy to read. Here, a question for you. Why do you think it's so widely used in this aspect where you have a lot of data to handle?
Sorry, can you repeat the question?
Sure. Why do you think it's used so widely in this in aspects where you have a lot of data to process?
So as I mentioned before, the Scala language is widely used because the expressive syntax and functional programming features that it has. They make a well-suited language for writing distributed data. Distributed data processing and applications. So one of the examples that I mentioned before is the Apache Spark framework, where you can easily have a lot of data and transform it with the framework that Scala and Apache Spark has for it.
Okay, thank you. And I guess following that, we have a question on chat. What are some advantages of using Scala when compared to, for example, Java, Python, C++, so many others, when it comes to software development in particular?
Okay, so one of the advantages is the conciseness that Scala has, because the syntax is concise. So it allowed to write more functionality with fewer lines of code compared, for example, to languages like Java. So this will give us the possibility to improve the productivity, and it makes it easier to maintain. Another feature that we can mention is the functional programming. So Scala embraces functional programming paradigms, which promote immutability, high-order functions, and pattern matchings.
Okay, and in addition to that, if we are looking to learn a new language, why should we consider Scala? Oh, yeah, I think we lost Miguel there at the end. Sorry about that, guys. I think we're going to have to put an early end to it. But remember that you can always find Miguel in our chats if you have any further questions about Scala. And of course, if you want to see the presentation that we received or ask for any more material that Miguel may have used for his presentation. In any case, for now, that is all from us. Thank you for coming. And remember to sign in next time when we have another Lunch and Learn next month. Thank you very much, everybody.